This problem is number 3 in the textbook out of section 3.2, and it is similar to the homework problem 3.2 number 3. So we are asked to maximize this function 4x plus 3y, and to do so what we're going to need to do is find these corner points. This one here at the origin, this one up here, this where the two lines intersect, and this one down here on the x-axis. Well, this point right here, that's just the origin, so we have those coordinates, 0, 0. This point up here, this is the y-intercept, and if we look at this equation right here, that's the equation this is the line that intercepts the y-axis. And when we let x equals 0, put 0 in for x, we'll get y equals 4. So the coordinates of this point are 0 for x, 4 for y. This point down here, that's the x-intercept. So if we look at this equation here, that's where this line intercepts the x-axis. And what we can do is this is y equals 0 here, right? And we want to find the x value. So how about if we just do this? Why don't we say that 0 is equal to negative x plus 6, and we'll add x to each side, getting x equals 6. So this point has coordinates 6, 0. Now, to get this point right here, this is where these two lines intersect. We need to find where this line here and this line here intersect. So we can do that if we just solve this system of equations. We're going to have y equals negative 1/2 x plus 4, and y equals negative x plus 6. And we can do this by just setting, right, y is equal to this, y is equal to this. So let's just set these two equal to each other. So we're going to get negative 1/2 x plus 4 is equal to negative x plus 6. Now, I've got a fraction in this equation. The way I like to do this is get rid of all the fractions. The LCD here is 2. So I'm going to multiply both sides of this equation by 2. It'll look like this. 2 times negative 1/2 x plus 4 equals 2 times negative x plus 6. So we'll get, when we distribute, 2 times negative 1/2 is negative 1x plus 2 times 4 is the 8 equals 2 times negative x is negative 2x. 2 times the 6 is plus 12. Why don't we do this? Why don't we add 2x to both sides? So if we do that, we're going to get negative x plus 2x is x plus 8 is equal to negative 2x plus 2x is 0. This will give us a 12. Subtract 8 from both sides. We'll get x is 4. And then, if x is 4, we can just put that 4 maybe right back up in here, simple, no fractions, to get y. So let's do that. So what we'll get is that y is equal to negative 4 plus 6, y is equal to 2. So this point of intersection is at 4 and 2. So now to find the maximum, let's just make up a table here. How about if we have a column for x, a column for y, and a column for our 4x plus 3y. And let's just go around and put in this point, this point, this point, this point, and see what we get. So let's start right here with 0, 0, and we'll get 4 times 0 plus 3 times 0, that's just 0. Why don't we come up here, put in this point, so that's going to be x is 0, y is 4, so we're going to get 4 times 0 plus 3 times 4, that'll give us a 12. Now let's go to this point. This is the one we found down here at the bottom, 4, 2. So 4 for x, 2 for y. We'll get 4 times 4 plus 3 times 2. Well, this will give us 16 plus 6 is 22. And then finally, we can put in the coordinates of this point, and that'll give us x is 6, y is 0. We'll get 4 times 6 plus 3 times 0 is 24. And we can see that the maximum value of all of these points is right here at that 24. So let's claim now that 4x plus 3y is maximum at 24 when x equals 4, y equals 2. And we'll write our conclusion like that.